Okay, so we have Math 2, Unit 6, Worksheet 2. Get a little bit there. All right, so we're going to do the odds. That was what your homework was. So we're going to go through the odds solutions to help you see how well you were doing with those solutions. So 1 through 6, determine if the triangles are similar. Complete the statement of similarity. State the postulate or theorem that justifies the similarity. If not similar, write not similar for both, A and B, and explain. Okay, so remember we have 3 ways to prove that 2 triangles are similar. And let's write those out right up the top here. Remember we have angle, angle. Okay, angle, angle. We have side, side, side. And finally we have side, angle, side. Now remember, angle, angle means 2 angles of one triangle have to be congruent to 2 corresponding angles of another triangle. Side, side, side means the 3 corresponding sides of one triangle have to be in a ratio or in proportional to the 3 corresponding sides of the other. And in side, angle, side, we have to have 2 corresponding sides in one triangle proportional to 2 corresponding sides of the other triangle, and the included angle be congruent. All right, so let's go. Let's see what we got here. Well, we've got parallel lines, and whenever we have parallel lines, you better be thinking about parallel line theorems. So we can actually say that angle A is congruent to angle D because parallel lines cut by a transversal, corresponding angles are congruent. We can actually say the same thing about B and E. Okay, so we have angle-angle theorem. So we can say that triangle ABC is similar to triangle DEC by angle-angle theorem. Pretty simple. Okay, let's see what we got here. Well, we want to show that triangle PQR is similar to triangle XQZ. Well, how do we know this? Well, let's look at what we have. First of all, we've got a bow tie, so we know that vertical angles are congruent. Now I can also look at the short side of this triangle and the short side of this triangle and put them in a ratio of 6 to 8, and it should equal the ratio of 9 to 12. And again, how did I know to pick these 2 together? Well, 6 is shorter than 9 and 8 is shorter than 12. So I think 6 and 8 go together and 9 and 12 go together. And of course, both of those reduce. 2 goes into 6 3 times, 2 goes into 8 4 times, and 3 goes into 9 3 times, and 3 goes into 12 4 times. So we have the corresponding sides are proportional and the included angle is congruent. So we can say triangle PQR is similar to triangle XQZ. Now, how do I know that it's PQXZ? Well, PQ is shorter side, XQ is the shorter side. So I know it's PQR with XQZ. And did any of you notice that QX doesn't look shorter than QZ, but that's okay. We go with what the numbers are telling us. And we know this by side, angle, side postulate. Oh, you know what? I did 1 and 2. I'm only supposed to do the odds here, so you got lucky here. All right, so number 3. Let's see what we got here. Well, you see how we have 3 sides, 4, 5, and 7, and we have 8, 10, and 15. Well, if these triangles are going to be similar, then the corresponding sides would have to be similar, which means the 2 short sides, the ratio of the 2 short sides would have to equal the ratio of the 2 middle sides, and which would have to equal the ratio of the 2 longest sides. So basically what we're saying is 4 over 8 should equal 4 over 8 should equal 5 over 10, which should equal 7 over 15. And let's see, well, this reduces to 1/2, and this guy reduces to 1/2. 4 goes into 4 once, 4 goes into 8 twice, 5 goes into 5 once, 5 goes into 10 twice. But unfortunately, this does not reduce. So these two triangles are not similar. Just because of that one ratio right there. Okay, moving on to number 5. Okay, let's see what we got here, number 5. So we're going to learn more about these guys tomorrow, but we can see that this angle is congruent to this angle. And if this is a 90-degree angle, then this guy has to be a 90-degree angle. So we know that PQR is similar to RQS. How do we know that? By angle-angle theorem. Okay, let's go on. Okay, what do we got here? Looks like we're going to have to draw a picture. Anytime there's not a picture in geometry, you better be ready to draw a picture. All right, so number 7. A 6-foot tall man is standing next to a tree. So you got to draw a picture. So there's a 6-foot man, kind of got a long neck. And then there's a tree. A skinny tree, but it's a tree. Okay? And the man is 6 foot tall. Okay, a 6-foot tall man is standing next to a tree. The man's shadow is 4 foot long. So if we drew his shadow, that would be 4 foot long. Okay? At the same time, the shadow of the tree is 10 feet long. Okay, so now we want the shadows to end in the same place. But the man's shadow is 4 feet and the tree's is 10 feet. So that would be 4 right here plus 6. Okay? And we want to know how tall is the tree. All right. So let's think about our ratios. If we think about this as two triangles, we could say 4 is to 10. 4 is to 10 as 6 is to x. And, we could reduce to 2/5, but these numbers aren't that big. Let's just cross multiply. 4 times x is 4x. 6 times 10 is 60. Divide both sides by 4, and we get x equals 15. So the tree is 15 foot tall. Okay, so you're probably going to do something similar there in number 8. Oh boy, I didn't leave you much room, did I? Hopefully you saw that okay. So I said the man's was 6 foot tall and had a 4 foot shadow. We were looking for how tall the tree was, but we knew it had a 10 foot shadow. So 4 plus 6 equals 10. And we drew that triangle. Remember, we're always going to draw triangles. So we said 4 is to 10. Okay, 4 is to 10 as 6 is to x. Okay? All right. Moving on to number 9. Okay. Victoria wants to find the height of a flagpole. Well, let's draw a flagpole. Okay, and there's a flag. Okay, there's our flag. Victoria is 5 foot tall. Let's draw Victoria. She's 5 foot tall. Whoops, I guess I didn't draw Victoria very well. There you go. Okay, and she's 5 foot tall. Stand next flagpole. All right, let's see. The flagpole shadow is 70 feet long. Okay, 70 feet long. And her shadow is 12 feet. So 12, and then 70 minus 12 would be what, 58? Okay, so if we draw that triangle right there, it's basically the same thing we just did. Okay, we're going to say 12 is to 70. 12 is to 70 as 5 is to x. 12 is to 70 as 5 is to x. Okay? Here's the cool thing. We could also say this. We could say that 5 is to 12. So the height versus her shadow is equal to the height versus its shadow. All right, you'll notice when we cross multiply here, 12 times x is 12x, and 70 times 5 is 350. Well, 12 times x is 12x, and 5 times 70 is 350. Divide both sides by 12. Let's see. 12 goes into 35 twice with 11 left over. Oh boy. Let's get our calculators out. I think it'll be easier. Well, let's just do it. Let me do it over here. Okay, 12 into 350. So 12 goes in there twice. That's 24. That's 11. And 12 goes into there 9 times. So that's going to be 18. Carry the 1, 9, 10. And 2. We better bring down a 0. And it goes in there once. So we're just going to call it 29.1. Close enough. So the flagpole is 29.1. Well, it's probably going to be 29.2 when you get right down to it. But you'll notice I could say that her height, the ratio of her height and her shadow is equal to the ratio of the height of the flagpole to its shadow. Okay? Or we could say, originally what we said was her shadow over the flagpole shadow is equal to her height over the flagpole's height. Okay? All right, moving on to number 11, 11 through 14. Explain why the triangles are similar, then find the value of x. Okay, well, let's see, are they similar? Well, we have two angles congruent, so by angle, they are, which tells me that 7 over 21 should equal x over x plus 4. And of course, we can reduce this to 1 over 3 equals x over x plus 4 to get a scale factor, and we will cross multiply. 3 times x is 3x, and 1 times x plus 4 is x plus 4. If I subtract an x from both sides, I end up with 2x equals 4, which means x equals 2. Okay, and we know this by angle postulate. I'll leave 12 for you. Okay. Number 13. Let's see what we got here. Oh boy, this looks complicated. Well, let's see what we got. Okay, well, we know they've got some angles in because those are vertical angles, right? Now we can say the short side over the longer, well, the short side over short side, if you will. 9 over 12, okay, which reduces to 3/4, should equal 21 over 28, which again reduces to 3/4. So by side, angle, side, these two triangles are congruent, which means we can take that scale factor of 3/4 and set it equal to 3 is to 4 as 18 is to x plus x minus 4. So we cross multiply. 3 times 4x is 12x, 3 times negative 4 is negative 12, and 4 times 18 is 72. We add 12 to both sides, we get 12x equals 84. Divide both sides by 12 and we get x equals, what do we get? 7, right? And think about it. 3 times 3 is 9, 3 times 4 is 12. Okay? 3 times 7 is 21, 4 times 7 is 28. And if we plug that in, that's 4 times 7 is 28 minus 4 is 24. 3 times 6 is 18, 4 times 6 is 24. And this was by side, angle, side postulate. Okay, let's keep going. Got just a couple more to do. All right, again, I mentioned this earlier. We're going to learn a lot about this. You might realize that there are 3 right triangles here. We have this big right triangle, we have the middle-sized right triangle, and we have the small right triangle. And all 3 of those triangles are proportional. We could say this small triangle, AD, we'll go ABD, is proportional to this middle-sized triangle, a little bit bigger. And the middle-sized triangle is, we went ABD, so we're going to go BCD. And it's proportional to the big triangle, which we're going to have to flip over to make it match up. But it would be ACB. So we go to B and C, and this is A. So ABD and BCD and ACB are all similar triangles because they all have a right angle, so that's one angle that's in common, right? Okay, and if this is 56, then that's got to be 34. And if that's 34, this angle right here has got to be 56. So you can see, because 34 plus 56 is 90, and 34 plus 56 is 90 plus 90. And so that means they all have these three angles in common. Okay? So what do we want to do? We want to find x and y. And so we can say that, well, we need a scale factor, don't we? And so if we see that AD is 2 and BD is x, okay, and let's see, we know that AC is 10, 8 plus 2, and we know that DC is 8, okay. Let's see, what else do we know here? We know this is 10, we know 2, we know x. Let's see, do we know BC? No, we don't know BC. Okay, we know DC is 8, okay, and x. BD is, let's see, AB is y, right? Okay, so we need one more piece. Oh, there it is. No, BD is x, okay, 2x and y, and the bigger one we have BD is x, we don't know BC, but we know 8, and on the big one we have 10, and we have y, and we don't know this guy. So let's see, 2 over x. Okay, so look at this, we can say that, let's see if this is going to help us. We can 2 over x equals x over 8. So AB and BD, so we can say that AD over BD equals DB over DC. Because these three guys are all proportional. These three are all proportional. And these three are all proportional. So we're going to say 2 over x should equal x over 8. We think, well, how does that help? Well, we cross multiply, we get x times x is x squared. 2 times 8 is 16, and we take the square root of both sides, and we get x equals 4. Pretty cool, okay? So now let's see if we can do the same thing with these two guys. We can say 2 over y. 2 over y equals y over 10. We cross multiply, we get y squared equals 20. We take the square root of both sides, and we get y equals 2 root 5. I don't know if they asked for that, but that's what we get. Okay, so you know what I didn't use? I should have used these all three, but let's look at this. This is ABC, or ABC, and then this middle one was BDC. And this one is ADB, from big to small. And if we look at each of these, let's look at the big one. We know that this is y, we know this is 10, and we don't know anything about here. The middle one, we know this is x, we know this is 8, and we don't know anything about the hypotenuse. And on the little one, we know this is 2, and we know this is x, and this is y. So basically what we did is we said 2 is to x as x is to 8. And then we said 2 is to y as y is to 10. And we found those two. So I did it all upstairs. I didn't realize I had the whole thing there for me. Okay, we're going to talk about that guy more tomorrow on some new notes.